In this one, we will see everything about handling missing values in R. But why missing values even matter? Why should you learn about it in the first place? The reason is, in most data science projects in real world, you might get the data from multiple different sources and the chances are some of them contains missing values. So how to detect, find, remove or replace these missing values is very essential step before you move on further in your data science project itself. First, let's create the clicks28 vector and insert some missing values in it. Clicks28 represents the number of clicks coming into the pizza company's portal for the 28 days. Now I'm going to create it as a random number using runif that ranges between 3000 and 4000 for 28 days. In R, missing value is represented by the notation NA. So wherever you find NA in any of the R code that you will find, it means that it is a missing value. I'm going to randomly place it at a couple of locations at 10 and 21. Now clicks28 contains couple of NA values, that is missing values. Now like how NA represents missing values, INF represents infinite values. Infinite in the sense when you divide any number by 0, you get infinity. It is that infinity that is represented as INF here. Let's place 1 in position 25. Now let's pretend that we did not create clicks28. Let's imagine that you got the clicks28 vector from a different source. Now given this vector, you want to find out if there is any missing value anywhere of in any of the positions of clicks28 or not. To do that, use the any function. It is very commonly used. If you pass any vector to any NA, it will just tell you if there is any missing value inside it or not. Returns true, which means there is a missing value in clicks28. Now, an alternate method to do the same thing is using the percentage in percentage operator. So what this syntax essentially means is it checks if NA is present in any of the values in clicks28 or not. On running this should return the same result. Both of these two notations are equivalent. Out of these, my personal favorite and I think the most commonly used one is any NA function. It's a base R function and quite commonly used amongst R programmers. Now you know that there is a missing value, but where is that missing value in that clicks28 vector? To check for the presence of any value, not just missing value, to check for the presence of any value, you can use the double equal to notation. It checks if each of the items of clicks28 equals to 3308 or not. You will have true only in the position where the value is 3308. Now, if you try to do the same thing with NA, trying to find the position of NA in clicks28 vector, if you try to do the same thing, you will get NA throughout. So this is not the right way to check for missing values in any given vector. So what is the right way? You need to use the is.na function. You will find this is.na function throughout R code of most people. It is very, very common. So wherever you find true, it means the value is missing. Now let me store it in NA mask. Likewise, if you want to negate it, that is values that are not missing is NA, you can use the bang sign, also called the exclamation mark, just before is.na and you will get the not NA mask. Now, similar to how there is is.na for missing values, there is is.infinite for infinite values. Wherever there is an infinite value, it will have true. Now let's look at how to remove missing values. A very, very common way to remove missing values is using the not NA mask. That is the mask that holds true whenever the value is not missing. This holds true whenever the value is not missing. By passing this to the square brackets, you will get all the non-NA values. Notice that the INF is not omitted when you use a not NA mask. Alternate and a fairly common way to do the same thing is NA.omit. It also gives the same result. This is the actual data that is being returned by NA.omit. But additionally, you will also receive couple of attributes called NA.action and class. These attributes are like meta information of the output of this particular function. Both of them are equivalent. My personal favorite and most commonly used is the direct bracket notation. Now, how to replace these missing values? This is Clex28. So, I'm going to store the positions where there is missing first. And then in those positions, I will replace those values with the value that I want to replace it with. So, how to find the positions? Previously, we visually saw where the missing values are using the trues and false. Now, I want to get the index positions. You can get that by passing the mask, that is the NA mask of Clex28, to the which function. So this will give you the positions where the values are missing. Now pass this NA position to Clex28, you will get the actual values. That is, it should be NA values. Now replace it with the value that you want to replace it with. Looking at the output of Clex28, we have 3500 in couple of positions. Now, if you want to replace each NA with different number, combine those numbers as a vector and then make the assignment. So here it is 3500 and 3700. Now, what if there are more missing values and you just use a lesser number of numbers within this replacement vector? What will happen is this vector gets cycled over again and again. So if there are four missing values and you are passing this vector, the third and the fourth NA positions will again be replaced by 3500 and 3700 respectively. We will see more about how this will actually work in an upcoming video. For now, understand that the values get cycled. Now, sometimes when there are missing values, you would go for removing them and sometimes you would go for replacing them. Typically, when you have a very large number of data and there is no dearth of data points in your data set, you might want to remove the less number of data points if you feel that it does not affect the results of your analysis. But given a condition that there are very few data points, maybe less than 30 or even lesser, it is a fairly logical way of replacing the missing value. A fairly logical thing to do is to replace those missing values. But what values we want to replace it with? If you ask, we could either replace it with the mean of the data, that is a very common thing to do, replace it with the median of the data. So these concepts we will be covering later on in the course when we see imputing missing values. But for now, to understand how to work with vectors, when the data is small, replace it with a value that is most likely to occur in that position. That is the fundamental understanding you need to have when it comes to replacing missing values. Now let's do a mini challenge. So this is the challenge for this video. In a recent survey sent to 1000 people, respondents rated a thin crusted pizza out of 10. Some of them left it blank. Find these blanks and eliminate them. Now the source code for this particular challenge is available here. You will need the pizza TC score object in order to do this exercise. You can either copy this code from here, go to this URL, or just run this line of code on your RStudio. You will have the necessary data to do this exercise. Give it a shot. I will show you the answers in a few seconds. So here's the answer. On running source of this particular URL, I will have the pizza TC score ready in my console. Now the solution is this. Congratulations if you got it right. Now you know how to handle missing values in R. I will see you in the next one with another important concept.